This is problem 39 on chapter 10. It's a conservation of angular momentum problem. Imagine that we have a merry-go-round that has 120 kilograms of mass and a radius of 1.8 meters, and it's rotating at an angular velocity of 0.5 revolutions per second. The question is, what's the angular velocity after a child jumps on the merry-go-round and sits on its outer edge? And it's a 22 kilogram child. So first we have to calculate the I of the merry-go-round, which we'll call I disk. That's 1/2 mr squared, 1/2 times 120 kilograms times 1.8 meters squared, and that has a total of 194.4, and the units are kilograms meters squared. We also have to add the I of the child, which is considered a point mass. It's just a mass at a point on this merry-go-round. So that's just mr squared, which is 22 times 1.8, which is 71.3 kilograms meters squared. And if I add that, I get 256.7 for a total. Moments of inertia add. So when the child's on the merry-go-round, his inertia and the inertia of the disk are simply added together. So conservation of momentum says that the initial momentum, which is the moment of inertia times the velocity, is equal to the final. And we're being asked to find W final. So that equals I0 over IF times W0. I0 is 194.4 and IF is 256.7. So we expect the final velocity to be less, and the velocity is 0.5 revolutions per second. So the final velocity, angular velocity, is equal to 0.366 revolutions per second. And if I wanted to know that in radians, I would multiply by 2 pi, which is 6.28 to get 2.3 radians per second.